All right. Well, that's way too big. Way too big. Still too big. There we go. All right, so let's start. So let's do chain rule. So chain rule basically says if I have if I'm taking a derivative of some function. Your book likes to use this U notation. I like this notation. It's a little bit better. It just presents both. So if I have if I have a compositive function, like a function inside of a function, right? In order to do this, I'm going to take the chain rules basically says take the derivative of the original function and then multiply it by the derivative of the function on the inside. And so what we're going to do is we're going to use splitting things this way. And kind of like this here, if I do dy, du, du, dx. And so here's a nice way of kind of splitting it up. So if I have some u, I'll do this. So let me kind of explain it using this picture real quick. This thing's much easier, harder. It's easier to see in demonstration than to explain with formulas. So here we have a graph of sine of x and sine of 4x. And so here, we're not going to sketch. We're just going to look at this. Is it possible? So here, let me just write this out. See if I can explain this the best way. So here I have sine of x. Oops. Sine of x. Of sine of x. Y prime of sine of x is cosine x. Right? So here, if you're looking at it here, y sine of x, right? Here, my derivative, my rate of growth right here is 1. And let's go ahead and just do this in a fun color real quick. Let's just use yellow. So here I'm at my little rate here is 1, right? And then here I've leveled off, and so my derivative here goes to 0. And so here I was going to draw this in. Let me actually use something a little bit deeper than yellow. Let's use a red. Let's make it more red with pink. All right, so here my derivative, something vaguely like this, right? And so here, because here the derivative is 1. So the slope here is about 1, right? And then here the slope here is about 0. So it's at 0. Because remember, I drew this in red. This measures the slope. Now let's look at the sine of 4x. Let me go back to my blue. So here I have sine of 4x. Is that the question here? The question here is that equal to cosine of, is the derivative equal to cosine of 4x? Well, sure, it runs through cosine. It'll still follow the same pattern, right? It comes up, it goes down. So here it zeroes out, here it zeroes out, here it zeroes out. So it's just going faster. However, this slope right here is much steeper than this slope, right? It's much steeper because it has to go up much faster. And in fact, it's 4 times steeper. And so what it really is cosine, this is 4. Oops, I'm on the wrong layer. I always am. And so it comes up much steeper, and therefore this 4 matters, right? And so it becomes 4 cosine of 4x. So what does that really mean? What we're really doing here, oops, let me put this 4, it should be this way. That's fine. And so what happens here is we're going to say, what your book wants you to say is, we're going to let f of u equal to sine of u. And we're going to let g of x, which is equal to u, equal to 4x. And then we'll apply, and so here for the chain rule, I'll explain it this way and then I'll explain it the other way. Therefore, the chain rule of y prime is equal to f of u, so the derivative of this with respect to u, so it would be cosine of u, times the derivative of this, which is 4, But if we put the 4 up front and then replace u back with what it is, 4x, cosine of 4. Okay. And I kind of just wanted to show you the way the book does it for a second. And then I'm just going to kind of run through a whole bunch and just kind of explain the song and dance of it. So notice here that this is much deeper. And so cosine's not enough. We need to do something else. And that something else is the 4. So I'll leave this up for 1 second. And then we'll switch. And then I'll go to the next page. And then it should make it a little bit more clear. How do you determine which is f of x and g of x when you look at a given equation? We'll be doing that a lot in on the next page. I'll clearly define which one's which. Oh, my drink's right here. I want to go get it. Right next to me. Can you show the graph? Sure. You don't need to put anything on the graph for the notes, but there you go. Okay. All right, so let's do the next page. For my friend who direct messaged me, remind me at the end of class, okay? All right, so let's look at this. Let's do a whole bunch of these. All right, so here I'm going to define 2 functions. I'm going to define a function u to the 7th, and I'm going to let u equal to 2x3 plus 1. Or the way I like to do it is I like to keep everything but I don't really like doing this per se. I like to say, I guess this is fine. Let's just use this for now. Let me kind of keep what your book's doing. That way, when you do the homework, it makes more sense. So here, I'm going to look at this function. I'm going to say, all right, this is a composite of 2 functions. So if I call this right here u, our function f looks like u to the 7th, right? And then what's inside, and we'll just say that's u, right? But what we really do, and so when we do this, we're going to take the derivative of this. So this is 7 u to the 6th multiplied the derivative of this. And so the derivative of this, oops, that's a 2. Sorry, that's that 2. Will be 6x squared, right? Because I bring down the 3, and this just becomes 0. So this is fu prime, and then gx prime. And then you multiply the 2 together. And so here, k prime, which is what we have here, is equal to 7 2x cubed plus 1 to the 6th power times 6x squared. And after you do this a couple times, you won't actually write out what is u and do this and then do these minor steps. You'll just say, okay, I'm going to take this, drop it up front, lower it by 1, and then take the derivative on what's in the inside and kick it out. Okay? I have a feeling I meant to write something else here. I really do. Oh, no. I know what I did there. That's fine. All right, so let's do this next one. All right, for this next one, here I'm going to let u equal to 3x minus 1, and then the master function here would be this. Okay? Would you have to simplify that for a? No, just leave it for terms of the no, I would leave it like this. In fact, this is probably the simpler form. If you expand it out and put it all back together, it would turn into a bigger mess. Oh, can I put the 6 and the 7 you could put together easily, sure, right? But everything else I'd kind of leave it as is. Okay. And so the way this works is you take the derivative of the original function, and then you take what's on the inside, and you just take the derivative of that and multiply it. Here, we're going to still declare what u is. We're going to let u be this function, or which is also our g of x function. And then here we'll let f of u, or f of g of x, be the square root of u. And so you basically say what's the function on the outside and what's the function on the inside. So what's being composed with what. So here, in order to do this, I'm going to take this derivative, and I'm going to rewrite this as u to a half. So it makes my life easier, because then the derivative here is 1/2 u to the minus 1/2 power. Here, this with respect to x is just 3. And so when I do this all across, I'll have k prime. Oops. Make my primes look a little better. Will be the derivative of f of u. So it'll be 1/2 u. What's u? Well, u is 3x minus 1 to the minus 1/2 power, multiplied by what's on the derivative on the inside, which is 3. And then if I simplify this one I can simplify as 3 halves 1 over the square root of 3x minus 1. Okay. All right. Let's do the next one. All right. So here, I'm going to let my original, is be the cubic root of u. And I'm going to let u equal to x squared plus x plus 1. Oops. F of u. All right, now f prime of u is equal to, well, let me rewrite f of u first. This is the same thing as u to the minus 1/3 power, okay? These two are the same. Then let's take the derivative, because then it's real simple. u to 2/3, oh, no, minus 1 would be minus to the 4/3 power. Here, if I take u prime with respect to x, I get 2x plus 1. And so therefore, k prime is equal to this. It'll be minus 1/3 u, but u is the following. So it'll be x squared plus x plus 1 to the minus 4/3 multiplied by this derivative here, 2x plus 1. Okay. All right. And so let me show you how to type in one or two of these into the computer to check it. Hello. Let's open up the Wolfram Alpha. Wolfram Alpha. No, that's just Wolf. Apparently I need to type in more. There we go. And so remember just to type in any derivative. You're going to type in d dx, and then here we're going to use sqrt to represent square root. And this. And then here we get to see that this is the same as we had, 3 over 2 over 1 minus that. So here, this simplifies to the same thing we got. Okay. This is how you type it in. So please double check your answers before you type in anything. See if I can type in the next one here. So here I want to take 1 over, which is not the square root. I don't think I typed this in the way I type it in. That's how you type it in when you're typing it up in LaTeX. I don't know if it's going to read that correctly. No, it does not. Check. Okay. We'll just type in it the way Oh, good. Now it reads it correctly. And did I put in the right G? No. X squared plus X plus 1. All right, so notice what we get here. Now, does this look like our answer? Not quite, but it's close, right? Because here, if I have this 1/3, they just put the 3 down here, right? Here I have my G, which is right here, into the 4/3 power, so they just put it back down on the bottom. And then here I have my 2x plus 1 up top, okay? So one thing I want to also show you as we do this is, how do I know that this looks the same as this, okay? Any questions on any of the stuff we've done so far? Let me do a couple trick stuff. I have some trick things here on purpose. Is there a difference between dx to yes? Yes. There is a difference. And so let me explain that real quick. Dx is an operation which you perform on something, right? Dy dx is the operation already performed upon the function. And that might seem kind of strange. This is the derivative with respect to y. This means take the derivative of whatever's inside. Is it really all that different? No, but in the next section, I'll address that much clearer, right? Okay. It'll be addressed a lot more clear in the next section. All right, so here for D, what would be my two functions? What would be my two functions I would use here? For D, which, if I was going to split this up to use chain rule, how would I use this? See if you guys can give me some of the answers real quick. Yeah, so here, U is equal to U cubed, and then my U is equal to cosine of T. Okay. And here we're going to be doing with respect to T, because that's my independent variable. So here, this becomes 3U squared. If I take its derivative, so this is my f of U. So my f prime is this. And then here, this cosine becomes minus sine. So U prime is minus sine T. And so if I took this derivative, H prime is equal to 3 cosine squared T times minus sine of T. All right. All right, so go ahead and try to do this one on your own. Go ahead and try to do E on your own. Give it a try, and we'll go from there. Question in chat. Isn't it cosine cubed? Yeah, here I have cosine cubed. And then here, when I take its derivative, I get 3u squared, so it'd be 3. U in this case is cosine of t, so it's cosine. And when we put the little 2's, if it's for cosine, we usually put it on the word. Sorry, I can say this correctly. This is equal to, this more properly written would look like cosine of, that looks like a 5. Write it more properly, make it look more proper. This is another way of saying cosine of t cubed, right? And so here, this is the squared. Yeah, so here our derivative would be 3 cosine, because here when I take this, this becomes, the derivative of this is 3u squared, right? Yeah, because it's the derivative. Here I took, this right here is f prime, and this right here is g, or u prime, or g prime, depending on how you want to say it. Okay. Yeah, here. And here we, if I type it into a computer, we'll get the same thing. We'll get -3. They put the sign up front for some weird reason, then cosine squared. Well, I have it in x, but if I switched it to t's, it'd be fine. T and t. Yeah. Okay, so what you guys get for E? Anyone get that one? I took this derivative. Yeah, that's exactly it. So here, my large function is e to the u. Well, the derivative of e to the u is still e to the u. That's what it is, right? And then here, my small function, u, or in this case, I'll just write g. Now let me keep the same notation the whole time so I don't confuse nobody. So f of u. So so in my mind, I think this is the big function, this is the little function. Does it really have anything to do with big and little? No, it's just how my brain files it away. And it's like, here, u is -2t. Well, the derivative of that is just -2. So p derivative is, with respect to t, right, would be e to the u, which is -2t times -2, which you guys simplified to be -2 e to the -2t. All right. Now here's an interesting one. So let's look at this one. So let's pretend we have f of x secant e to the x. So here we're going to have secant u is going to be my f of u. And then here we're going to have u equal e to the x. And so here the derivative of this is derivative of secant. I should know this answer. Secant tangent, right? Let me double check that. Secant u tangent, oops. Secant u tangent u. And e to the x is still just e to the x. Okay. So here, this f prime would be in this case. I guess that's a terrible notation if I'm using an f. Let me just use q of u equals to that and q prime. Now I'm not using the f prime twice. So f prime in this case would be secant of what was on the inside, so e to the x, tangent of e to the x, multiplied by its derivative, which is e to the x. Okay. Everyone okay with? And here, if we just crunch that in, we see that's indeed what we get. Except they put the e to the x up front and the tangent up front. But still, it's the same. All right, any questions on any of this? Basically, it's a whole chapter on one concept. Okay, I'm not seeing anything. All right, so I've had this up for a little while, so let's do the last page real quick. All right, so now we can use chain rule. Oops, I don't want to do that. We can use chain rule in conjunction with a bunch of the other rules. And so here, I can use chain rule with power rule. I can use chain rule with chain rule. And here I can use chain rule with quotient rule. So let me show you how to do that, how to put all the pieces together in some way. So here I'm going to use, this is going to be my F and this is going to be my G, right? Because I need to use power. I need to use the product rule, right? I wrote power there. I want product. The word I wanted there was product. All right, so here I'm going to have e to the 2t prime sine of 3t plus e to the 2t sine of 3t prime. But notice here, in each one of these cases, we need to use chain rule, right? Because if I take the derivative of this, I'm going to get e to the 2t times 2. So this would be 2e to the 2t sine of 3t. Plus here, if I took the derivative here, I get cosine of 3t times 3. So this would be 3e to the 2t cosine of 3t. Does everyone see where I'm getting this 2 here and this 3 here because of chain rule? Yes, no, maybe? All quiet on the chat front. Yes, thank you, sort of. We'll go through it a couple times. You'll see it more and more the more you do it. Hi. So here, let me just kind of fuss with this for a second, right? And so here, it's going to take out the 2t every time, but it doesn't. See, if I had a 5 here, that 5 would appear out front. And if I had a 9 here, that 9 would come out front, right? And so often what you do with the rule is like whatever, there's usually like some sort of constant on your variable, and you can just pull that out front. That's usually what happens. Now, if this is more complex, you can do more complex things. Yeah. Wait, where does chain rule come into play here? Oh, this 2. So right here, when I took this derivative, it's e to the 2x, and this 2 is technically chain rule. And then here, when I took the sine of 3t, comes cosine of 3t, and then this 3 that came out is technically the chain rule. Does that make sense? Where the chain rule is coming into play? That's where the 2 and the 3 come out. Because I need to take this derivative plus the derivative on what's on top. So let's do this one. So this one, here I'm going to have u is equal, so here I'm going to have this equal to u square root of u, right? And then the next thing, I'm going to say u is equal to secant of, I better use, let's just say w, right? And w is equal to x cubed. And so here, I actually have kind of a long list of things, right? So it'd be, I need to take the derivative of this, which produce something and when I take this derivative, it's going to produce another thing. Let me see if I can explain that as properly as possible. So here I'm going to have f prime, u prime, w prime. That's what's going to happen here. So let's see if I can do this without horribly getting everyone lost. So here, let's do this. So this derivative of this is minus a half u to the minus 1/2, or it's positive 1/2 to the minus 1/2 power, right? We've done square root loads of times. Here, u prime is equal to secant becomes secant tangent. So for x anything and trig anything, we just pull out the constant basically. Yes, basically. Here, this becomes secant w tangent w. And what's w? X squared? Well, w prime is equal to 2x squared. Okay, so let's put this all together now. So k prime is equal to f prime w prime. So here I'm doing chain rule, and then this I'm doing chain rule again to get this w. So the first chain rule is going to give us 1/2 secant, and w is, so secant squared x to the minus 1/2 power. So that's the first chain rule. Then I'm going to take what the derivative of the inside is, which is secant x cubed tangent x cubed, secant tangent, because that's what the derivative of the inside is. But now I still need to take the derivative of the inside of that, which is equal to 2, or is equal to 3x squared. Sorry, that should be a 3. No, that did not look like 3. Okay. And so here we do a chain rule, and then we still have to do one more chain rule to keep things going. And so something as simple as SQRT of secant of x cubed. See if I can get this to do what I want it to do. Oh, did not do what I wanted to do. This is why I'm doing it. Yes, you're not doing as I ask you to do. Do as I ask you to do. All right, and notice here, that's what we get. Oh, they did a lot of funniness. They did a lot of funniness to get rid of the tangent, but yes, you can. I see what they did. I don't agree with what they did, but they did. This is indeed the same as ours. They just have they using the tangent. They use tangent, which is sine over cosine, and secant is 1 over cosine, and they combined all the cosines together to make it into a. That's the only difference. Okay. All right, we're making decent time. So let's do.
Professor?
Yeah, go for it.
What is that line that's behind secant x cubed?
Oh, that is me. That is, I was just trying to put, when I was explaining what I was doing, because I put in the cubes. So secant cubed x cubed, but then I need to take the derivative on what's the inside, and the computer just didn't grab it that well.
Oh, okay, thanks.
Yeah, sorry, that's just bad handwriting. All right, so let's do this. So now we can use it with quotient rule. So here we're going to let u equal to, so we're going to let our function be u9. I'm going to let u equal to t minus 2 over tx plus 1. So this derivative, so f prime and then u prime. And so f prime here is just 9 u to the 8. This here I'm going to have to use product rule. I remember product rule. It'd be squared. Gee, I always forget which way it goes first. All right. I think it's f prime. Pretty sure it's, because here you let this be f and g. You guys want to know what I actually do? Let me show you what I actually do. This is why I do not know how quotient rule in my head, because I will show you exactly why. And this is a good case to show you where. Oops, that's an 8. All right, so I'm going to rewrite u to equal t minus 2, and then 2t plus 1 to the minus 1 power. That way u prime is equal to, and then I just always have to use product rule, and since it doesn't matter which way I do, which one I do first, we're fine, but now I have the extra chain rule because of this. Because here, if I keep the first one, if I take the derivative of the first one, I just get a 1, right? And then it's going to be 2t minus 1 to the negative 1 power plus, keep the second one constant. So this derivative, so here I'll make this my f and this is my g. So f prime g, and then f g prime. So here I'll have a minus 1 that comes out because of this 2t plus 1 to the minus 2 times 2. And here I'm just using chain rule to avoid using quotient rule. It's really honestly what I do. Because I do not, I'm dyslexic, and therefore if like, if I always just do this, it doesn't matter which order I do it in, right? And so here, we'll have the final answer of k. Whoop. Hey, come on now. K equals 9 of t minus over 2t plus 1 over 8 multiplied by, let's go ahead and just write this the way we've written is 2t plus 1 plus minus 2 times t minus 2 all over 2t plus 1 squared. And there you go. Now, could you simplify this? Sure. If I simplify this, I just multiply this top and bottom by 2t minus 2, which would probably give you what you guys would do if you just naturally did the quotient rule, to be honest. But I did want to show you, because this would be 2t plus 1 minus 2 of t minus 2 all over 2t plus 1 squared. In this case, you can see where the derivative on the bottom is 2, so it'd be f g prime f. Is that a 2t? Yeah, that's 2t up top. And we'll just check this one real quick on the calculator, and then we'll just do the last set of notes. Make sure I didn't make any boo-boos. Something that large I might have. All right, so I want squared divided. Oops. Sorry, guys. 1 second. This takes a half second to type in. To the 9th power. This is going to be what I want. In fact, what it does is it pulls more things in. It just does. So it's a little bit more fancy than what we did. Okay. Because here it's going to multiply this to the top and to the bottom and then simplify and go from there. So that's why we have this as 10 on the bottom. And then it's going to complete this and does other math. Okay. So is the first, so the first and second one both should be k prime. All right, so we have 20 minutes, so let's get to the last 2 set of notes.